Hi guys, Mrs. Delizin here. Welcome to another lesson of Algebra 2. Today's lesson is adding and subtracting rational expressions. And we know that when we add fractions or subtract fractions, they have to have the same denominators, correct? Because if they don't have the same denominators, we have to find what we call the LCM, or the least common multiple of the two denominators. So what we're going to do today is first we are going to practice on how to find the least common multiple, or let's just say common denominator. Okay, and there it's a long process, but I'm pretty sure you guys are going to excel on this one. So let's imagine these numbers in 1a, these are all denominators. Like let's imagine we have, let's say, whatever, 1 over 1 over 1 over, right? They are all denominators. So our job is to find the common multiple between all three of this. So there's a lot of process to do it. There's actually some probably simpler ways to do it, but the one that I'm going to be showing you today is going to help us as we move forward. If we're going to have a factoring in it, we're going to do other stuff, right? It's applicable to all kinds of problems in rational expression. So here's what we're going to do. We're going to look at them one by one, and we're going to simplify the numbers. We're going to break the numbers into pieces. So we have 18. I will break 18 into 6 and 3. Right? Technically, I'm just going to show once. So I have 18 as 6 and 3, 8, 3 and 2. So I can break that into a 3 squared and a 2. So here, the 18 would be 3 squared, or maybe I'll put the 2 first. So I'll put 2, and then that is 3 squared. And then I'm gonna leave x squared and y squared on its own. Okay. Now for the 24, of course, later on I'm not gonna be showing the breaking part, but I'm pretty sure as we move forward, you guys are gonna do it all on your head. So I have 6 and 4, 2 and 2, 2 and 3. So I have three twos and one three. So that is 2 to the power of 3. I have 1, 3, and then I'm not going to break the x cube. I have a y and a z squared. If you notice, I write them in, like, I write them vertically and I write them in line, right? Like all the twos are together, all the threes, all the x's, and that's what you're going to be doing when we are doing another example later. Okay, I'm going to break the 15. I don't have to make a 3 and the 15 because that's just 3 and 5. So I have a 3 and I'm going to insert a 5 in there. The 5 seems to be alone. And then I have a y cube and a z. Okay, and what we're going to do now is we're going to find who has the most. So between the 2 and the 2 cube has more. Between 3 squared, 3 and 3 squared has more. Between x, oh, and then I have 5 on its own. Between x squared and x cube has more. Y to the fifth has more. Z squared has more. So here is what we call our common multiple. All we have to do now is to combine them. I have 2 cubed. 2 cubed is really 8. 3 squared is a 9. And then I have a 5. I have an x cube. I have a y to the power of 5, and I have a z squared. So we have to multiply 8 times 9 times 5. So 9 times 5, or 8 times 5 is 40. 40 times 9 is 360. Okay? So all you have to do is multiply all the ones that you have at the bottom. And then I have x cubed, y to the fifth, and z squared. And this is our least common multiple. Okay, I know it's a kind of a lot of process to do it. Yeah, let's start with the other example. We have 6, and I'm not going to be showing the tree anymore. Okay, we're going to do the breaking part all on our head. Let's start with 6m cubed n to the power of 5. So 6 is 3 and 2. So I'm going to break that into 3 and 2 first, and then 3. Let's write them in order. And then I have m cubed, and then I have n to the power of 5. For the 42, what is 42? 42 is 6 times 7. 6 is 3 and 2. So 1, 2, 1, 3, and a 7, right? 6 times 7 is 42. We have 1m, 1n, and a p squared. Okay, moving on with the 36. 36 is 6 times 6. And then 6 is 3 and 2, 3 and 2. So we have 2 2s and 2 3s, right? So technically that means 4 times 9. And then I have m cubed, n to the power of 4, and 1p. Okay, let's circle the one who has the most. So we have 2 squared is the winner. We have 3 squared is the winner. Of course, 7 is alone on its own line. So 7 is the winner. We have a tie between m cubed and m cubed. So we can just circle any of them. And then n to the power of 5, and we have a p squared. So let's write all of them. 2 squared means 4. 3 squared means 9. 7 is 7. We have m cubed, n to the power of 5, and p squared. So 4 times 9 times 7 is 200. This one right here is 252. So this is 252 m cubed, n to the power of 5, and p squared. This is the least common multiple, or as we commonly called as the common denominator. Okay, moving on. Oh, what if we have like factors, right? It's no longer like numbers, it's factors. Because it's a factor, the p plus 2 cannot be broken into separate pieces, right? P plus 2 is p plus 2. So I can't break that. I'm going to have to write that together at all times. So the p plus 3 has to be written also together at all times. Let us concentrate on this one first. I can write p and then p plus 2 and then p plus 3. I cannot break that apart. And then let's move on to the next pair. We have p plus 3 and another p plus 3. Does that mean, can I write that as p plus 3 squared? Right? Because p plus 3 and p plus 3 is p plus 3 squared. So let's write the winners. We have p in here. We have p plus 2 in there. And then we have p plus 3 squared in there. Okay? So our least common multiple would be p plus 2 and p plus 3 squared. Moving on. We are going to look at this. We have q minus 2. Again, you cannot break that, like you write the q on the other line and write the negative 2 on the other line. You cannot, because q minus 2 is together. That is one factor. But I have 2q minus 2, so I can write squared. And then at the bottom, we have, let's write q on the corner. I have q minus 1, and I have q minus 2. There. Okay? And then I have q wins on this column, q minus 2 squared wins in there, and then you have a q minus 1. All right. So your least common multiple, your LCM, is going to be q. I can write q minus 1 first if I want to. Q minus 2 squared. Okay, there you go. Now, we are going to actually try to solve a fraction. So let us take a look here. We have 5 over 12 minus 3 over 50. First, we have to find the least common multiple. And we cannot just say, okay, what I've learned from the past is I just multiply 12 and 50. If I multiply 12 and 50, I will get 600. But mind you, 600 is not, it is a common multiple, but it is not a least common multiple. So we have to find the least common multiple. And we learned 12 is 4 and 3, 4 is 2 and 2. So that is, oh, maybe I could write that over here in the corner. So I'm trying to find 12 and 50. Right? So 12 is 2 squared times 3. And then 50 is 10 and 5. And then 10 is 5 times 2, right? Let's write that down. We have 50 is 10 and 5. And then that is 2 and 5, right? So that is a 5 squared and 1, 2. Okay? And then that is who wins the in here, 2 squared wins, 3 and a 5 squared. So 2 squared really means 4, 3 means 5, and then 5 squared is 25. So you are going to do 4 times 3 times 25 and you'll get 300. So our common multiple is 300. So we have 5 over 12 minus 3 over 50 equals 300, 300. Okay, what do we multiply the 12 to become 300? I will repeat. What do we multiply the 12 to become 300? That is kind of like, oh, what do I multiply the 12 to become 300? You can also do it the other way around. What's 300 divided by 12, right? 300 divided by 12 is 25. So I have to multiply the bottom by 25 to be 300. And of course, I would have to do the same on the top. What do I multiply the 50 to become 300? In other words, what is 300 divided by 50? That is a 6. So I multiply the bottom by 6. I would have to do that also on the top. So 5 times 25 is 125. 3 times 6 is 18. Now that they have the same denominator, I can just subtract the top and copy the common denominator. So 125 minus 18 is 107 over 300. There you go. Now let's add letters to it. So what if we have some kind of a letter? Number 4. I have 15y squared and an 18xy. So let us find the common multiple first. So 15y squared, 18xy. 15 would be 3 and 5, so that's 3, 5, and a y squared. 18 would be 9 times 2, and then 9 is 3 squared, so that is a 2. A 3 squared, right? That's 9 times 2. And then there's an x to it, and there's a y. Let's circle the winner. 2 is the winner because it's alone. 5 is the winner. X is the winner. Y squared is the winner. So all we have to do is multiply all the winners. That's 2 times 9 times 5 times x times y squared. Altogether, we have 2 times 9 times 5 is 90. So our common multiple is 90x y squared. That makes sense? So let us write our problem here again. 7x 15y squared plus y over 18xy equals, this is a plus in the middle, 90xy squared, 90xy squared. Okay. Technically, what that means is, what do I multiply the 15y squared to become 90xy squared? So let's start with a number. What do I multiply the 15 to become 90? Technically, you can do it backwards. 90 divided by 15. 90 divided by 15 is 6. So I need to multiply the 15 by 6 to make it 90. I also, this one has an x, but this doesn't have an x. So I also have to give that x. I don't have to multiply it with y squared because my original denominator already has y squared. So what I'm doing here is I am multiplying this with what's not in it. Okay? And because I multiply the bottom by 6x, I will do the same thing to the top. Okay, let's move on with the other side. How do I make 18? What do I multiply to 18 to make it 90? Of course, you can do it backwards. What's 90 divided by 18? And 90 divided by 18 is 5. So I am multiplying this by 5. So maybe I have to, let's delete that equal sign in there and make it closer. Okay, I will multiply 18 by 5 to become 90. And I don't have I don't have to multiply with x because it already has an x, but I do have to multiply it with 1y because this one is y squared, but this one is only y. So I have to multiply it with another y. And whatever I do to the top, whatever I did to the bottom, I will do it to the top. Okay, so we have 7x plus 6x, that's 42x squared. Oh, let's go back to the color. 42x squared. 5y times y is a 5y squared. And because they have the same denominator, I can just write them all at once. 42x squared plus 5y squared. It does not look like they have something in common, right? The 5y squared and the 42x squared, they don't have anything in common, so we cannot simplify them anymore. Okay, here's the thing. Please do not forget domain restriction. We now have domain restriction because we have letters involved. Domain restriction is we want to avoid the whole bottom to become a 0. So what would be the value of y for the whole entire thing to become 0? If this y is a 0, the whole bottom becomes a 0. And we don't want that. So the y cannot be a 0. That is our restriction. And then in here, we have an x. That x cannot be a 0 because if that x is a 0, the whole entire bottom would become a 0, and we are not allowed to divide by a 0. Okay? And if you're confused, that's because you have not watched multiplying and dividing rational expressions yet. So I suggest that you watch that first before moving forward. Okay, another example. I'm going to skip that. Let's do 5b. First, we are going to get our LCM. LCM. There you go. For the 3, I have 3 and then x plus 1. For the next one, I have another x plus 1 and then x minus 5. So our LCM would be 3 wins, x plus 1 wins, and x minus 5. Alrighty. So we have x over 3x plus 1 minus 2 x plus 1 x minus 5 equals, or maybe I can put it at the bottom, equals minus our common multiple is, so I'm going to write that down there already. There you go. Okay, let's focus on the first denominator. We have 3 times x plus 1. And our least common multiple is 3 times x plus 1, x minus 5. So what do we need to multiply this so it can be equal to that? It has a 3 already. It has an x plus 1 already, but it doesn't have an x minus 5. So I have to multiply that with an x minus 5. Whatever I do to the top, I do it to the bottom. Or whatever I do to the bottom, I will do it to the top. Okay, moving on with the next. It already has an x minus 5, so I don't have to multiply it with x minus 5. It already has x plus 1, so I don't have to do that. But it does not have a 3. So I have to multiply this by 3, and I have to multiply that by 3. Okay, so we have x times x minus 5. I have to distribute the x, right? So I'm going to end up with x squared minus 5x. And then 2 times 3, of course, is 6. Okay, moving on. I am going to write giant. I'm just going to combine both of them together. That's x squared minus 5x minus 6. It looks like we still can simplify this, right? It looks like we can factor it. Let's see how to factor that. Numbers that when you multiply, you'll get negative 6. When you add, you'll get negative 5. That's negative 6 and a positive 1. Let's review. Negative 6 times 1 is a negative 6. Negative 6 plus 1 is a negative 5. So that is our answer there. But, okay, we need to look if there is something in common between the top numbers or the top factors and the bottom factors. In here, it looks like we have something in common. We have an x plus 1 on the top, we have an x plus 1 on the bottom. So they do get canceled. So our final answer would be x minus 6 on the top, and we have x minus 5 in the bottom. All right, so that is x minus 6 over 3x minus 5. Okay, domain restriction. Domain restriction is we need to make sure that the bottom cannot be 0. So what x value will I plug in there to make the whole thing 0? It's the opposite of it, right? So in order for that to become 0, if that x is a negative 1, then the whole thing will be 0. So I cannot afford for that x to be a negative 1. And then same through with this. And here, that x cannot be a positive 5 because if this x is a 5, 5 minus 5 becomes a 0, and we are not allowed to have a 0 in the denominator. Okay, there you have it. I am going to do one example from the homework just in case you need more examples. But I think at this point you're good to do your homework on your own. But just in case you need another example, I am doing number 3 on the homework page. So LCM first, that's what we do first. I'm going to write m plus 2 and then m minus 2. I'm going to write 3 and then m plus 2. So that's 3, m plus 2, m minus 2. This is our least common multiple. So that is m over m plus 2, m minus 2, plus 2, m plus 2. So we are going to figure out, I'm just going to write them all at once, yeah? That way, there. This is my least common multiple. What do I multiply this with to match with my common denominator for my common multiple? It already has an m minus 2. It already has m plus 2. It doesn't have a 3. So let's multiply that with 3. Whatever I do to the bottom, I will do to the top. Moving on with the other one. This one has a 3. It has an m plus 2, but it doesn't have m minus 2. So I'm going to multiply that and multiply that. Okay, so m times 3 or 3 times m is 3m, plus I can distribute this. 2 times m is 2m, 2 times negative 2 is negative 4. So our final answer there is m plus 2, m minus 2. I think I can combine these two numbers. So I can do 5m minus 4. And that is our final answer. Okay? We have 5m minus 4 on the top, and then we have our, of course, our least common multiple. Okay, now let's put our answer. Oops, wrong pen. 5m minus 4 over 3m plus 2, m minus 2. And then let's get our domain restriction, always the opposite of whatever it is. We have m plus 2. This m cannot be a negative 2. In m minus 2, that m cannot be a positive 2. Right? And then in this m, that m cannot be a negative 2, but it's already covered. So our domain restriction, our DR, our m can be any number, but it cannot be a negative 2, it cannot be a positive 2. Okay, and that's the end of it. Thank you guys for watching, and I hope this video will help you answer or work with your adding and subtracting rational expressions homework. Thank you.